Hello all, and welcome to our last week in our unit about proportions. So as a reminder, what this means is that you will have your test next week. So we'll have 2 more lessons this week on 8.7 today and another one on Thursday. And then after that, you'll have your quiz starting next Monday, a week to prepare. So you'll notice that there is a Zoom assignment to set up our Zoom meeting over the next 2 weeks before the test starts. And if you have any questions about this unit, you can ask me then. That's also when I'm going to be checking your notes and homework notebooks for the unit on chapters 7 and 8, talking about proportions. All right, now that we've gotten that good information, let's get started. So this week we're going to be talking about interest. This lesson's on simple interest. There's also an interest called compound interest that we'll look at on Thursday. So we're going to start by defining what interest means. So if I look at the formula for simple interest here, we have an I, and this stands for interest. Now, the definition of interest is the increase, so it is an increase, and it's by a percentage usually, increase in a loan or an investment. So a loan is when you owe money, an investment is where you are getting money. So loan is where you pay, and investment's where you get it. And it's an increase based on, you can see these 3 variables. So that is the original amount, which is P here, and this P stands for principal, which is just the original amount of the loan. The rate, which is R, and this is just going to be a percentage. And then T here, which stands for time, and this is always measured in years when we talk about interest. So if you think about like a commercial where they say APR, that is annual, is what the A stands for, so once a year percent rate. So you're always going to measure in terms of years here. Now, another important idea here is that the total here, total amount you owe, is equal to the principal, which is the original amount, plus the interest. So if you have an investment, you owe both the interest and the original. If you have an investment, you have the original amount you put in plus the additional interest. So let's talk about how to use this formula. How much money is $4,000 worth after 10 years if you have a 4% simple interest? So here, what we want to do is I always recommend that you start with the formula. So in this case, I is equal to PRT. And then it becomes the question of which of these do you know? Well, P is the original amount, so this would be 4,000. R is 4%. T is 10 years. And I is going to be what we don't know. So you'll always not know one variable. And I will also make the note is that we want the total. So we're going to have to remember that in our final answer, we need to add the 2 numbers together, the principal plus the interest, to get our final answer. Now, an important thing to note here is that when we plug into our formula, so I is equal to 4,000, when I multiply by the rate, I'm turning it into a decimal. So here, 4% is going to become 0.04 as a decimal so that we can put it into our calculator easier. And then 10. So from here, as you can see in the notes for the homework, absolutely encourage you to use a calculator for both of these units. Make sure you're writing down what you're typing into the calculator so I know that you're using the numbers in the problem and the formula correctly. So when we type that into our calculator, we end up with $1,600 as the interest on that loan. So as we remember here, our total is what we want. So we owe the $4,000 plus the interest. So the total value then is $5,600, and we are talking about dollars, so make sure that we're including our unit. Now, usually when we pay a loan back, we don't pay a loan, and this is going to be true in all your adulthood. If you ever take out a loan for a car, for a house, for any type of debt, you're not going to pay back that entire thing all the way at the end. What you'll do is you'll make a monthly payment. So if you think about this, how much would you need to pay each month to pay off the loan described above? So your monthly payment is going to equal your total divided by the number of payments or the number of months that you'll pay. So I often think about this as your total divided by 12 times t, because remember, little t is always measured in years. And there's 12 months in every year. So in this case, our monthly payment is, the total is $5,600. 12 times 10 is the number of years. So what this tells us is that we're dividing the $5,600 total over the 120 months that are going to occur during the time. Now, if you type this into your calculator, you're going to get 0.6 repeating. Now, since we want to round to the second place when we talk about money, because money has 2 decimal places here, dollars are out of 100. So I'm going to round correctly to 67. So while you have to pay off $5,600, you're only paying $46.67 a month, which is why monthly payments are so important to think about. Now, number 3, if you want to earn $100 in interest on a $5,000 principal, little typo there, every 2 years, right? So this is the idea of like a retirement account where you don't want to necessarily lose the principal. But if you want to earn $100 in interest on a $5,000 principal every 2 years, what interest rate do you need? So in this case, we have here, what interest rate do we need? So that means that we want R, and we have to know the rest. So we have to know I, we have to know P, and we have to know T, because you can only solve for one variable at a time. Now in this case, I is 100, P is 5,000, the original investment, and T is 2 years. So I'm going to use my formula. I is equal to P, R is my unknown, and T is 2. So we're just plugging in our different variables here. We're still using the same equation. I'm going to simplify the right side here, because 5,000 times R times 2, it's all multiplication. So I'll reorder that and just say 100 is equal to 10,000, since that's 5,000 times 2R. Divide both sides now by 10,000. And absolutely, you could use a calculator for this, but remember when we're just dividing with zeros on the end, divide out 10, divide out 100. So then this is 1 out of 100 is equal to R. R, as we've discussed, is a percentage. 1 out of 100 is 1%. So you can absolutely use a calculator, but sometimes it's just faster to not. All right. How long will it take a loan to double in value if you are charged 12% interest? So what this tells us here is that we want to know how long. So that means we want to find time. Now we know R, which is 12%, but it says, oh no, it says wants to double. So what that tells us here is that we don't know what our principal is, but we can pick a number because this is not going to make a difference. So you can pick any number you like. You can even just leave it as a variable. So if I just say P is equal to P, we know that we want the total to then be equal to 2P, because this is the idea of doubling. Doubling is multiplying by 2. Now here's where we're going to be a little sneaky, and I'll make this note off to the side, is that if our total is equal to P plus I, and in this case our total is equal to 2P, is equal to P plus something. Well, 2P is the same as P plus P, the principal plus the principal This is our idea of like terms. 1p plus 1p is 2. Well, we have same thing on both sides. So what this tells us here is that the principal has to be equal to the interest if the total is doubled. So you could have just picked a number there. That would have been just fine if you were like $100. What does it take to become $200? But we can also leave it as a variable and be sneaky like that. So if I'm using I equals PRT, the interest is equal to the principal, and then the principal, times R, which is 0.12. Remember, you want to turn this into a decimal. And T is our unknown. Now, whatever number you've picked, if it's $100, if it's $50, when you divide it out, when we divide on both sides, it cancels out here, but you'll notice it also cancels out on the left side. P divided by P, 100 divided by 100, 50 divided by 50, whatever number you have there is 1. So 0.12T is equal to 1. Now what you want to do is divide both sides by 0.12, so we can get T by itself, and so therefore the time is equal to 8, and it says 8.3 repeating. Years is always our unit for T. Now remember, 3 repeating is 8 1/3 years. You could have also said 8 years and 4 months. Either way would be just fine. Let me know if you have any question about simple interest in the comments, or leave a response in the form that's attached so I can know if you're stuck on any of the homework problems. Talk to you later.